Okay, so already you have gone through first sessional, right, regarding to this subject MFP. Any doubt in the first sessional questions? Any doubt in first sessional? Any question that any concept that you are not comfortable with, or I hope you have seen your marks. If not, do not check right now. It is given to you, but later on you can verify. Okay. So answer key of the sessional exam. If you have specific questions, specific doubt, that will be better if you can write down in the chat box. Okay. Okay, so in case, okay, so what we can do is, I will put, in case you need, in case you have doubt, you can ask that in the laboratory session as well, no issues, right? So we can discuss that later. Even if you want to ask me the questions, you can ask me in the mail, or you can ask me right now any question that you don't know, that you want to understand, right, regarding to your first sessional, right? And we will see that in the laboratory session, if possible, the question answers will be sorted out, right? So that we will see. Right now, if you have that question, any question before we start, before we go there and we want to solve, if you want to solve any concept before we move ahead, that you can ask me right now. Otherwise, what we can do is, some difficult questions that you can note down your questions which were difficult for you, and that these questions we can discuss in the laboratory session as well. Okay. But otherwise, if you don't have any concept that is not clear to you, then we can go to the next one. Okay, so here, is the screen visible to you, students? Is the screen visible? Okay, fine. Now, next session we will start with the next instruction, that is a loop instruction, right? Now, can you check? Is it fine? Janil, is it fine? Okay. Now, what we are going to do next is today's session, today's part will be loop instructions. We are going to learn about loop instructions. We are going to learn about rotate and shift instruction. We will have programs related to that. And then if time will permit, we'll go for string instructions, right? So new instructions we are going to learn. We will learn about the what you can say programs related to that. Okay, that is what today's agenda is. Okay. So loop instruction, what is that? It is like jump instruction only, right? But in jump instruction, how we generally use that, we have one counter, say cx counter, bx counter, ax counter, any counter we have. That counter will store some value, say cx, move cx is equal move cx 5, right? That means cx is having value 5. Then you are doing j and z, right? So you are decrementing cx and then you are using j and z. What is the meaning of that? You decrement cx and check whether that cx, whether the cx is 0. If it is so, then if it is not 0, then jump to certain location. That is how you were using it, right? So here, what are the things that we have a variable which is a count variable, right? It is having value it is having some value 5. That means your loop will execute it 5 times, right? So it is a counter variable we have. We are decrementing. We have one more instruction to decrement the counter, and then we are checking whether the value is has become 0 or not. That means zero flag is executed or not. If it is not executed, then continue with your loop. This entire process can be included in one instruction, that is loop, right? What loop does? The decrement cx part and that j and z part it does. Okay, so what we are doing, that it what loop does, it decrements cx. It is fixed to use cx. It is not like you can use any variable here. You have to use cx. And if you are using loop, then what loop will do? It will decrement cx, and then it will check, is it 0? If it is not 0, then it will go to the label that is specified. That is what is done here. So move cx5, and what this will do, this will jump to next if cx is not 0, right? And then after that, what it will do, it is also decrementing your cx by 1. Okay. One more instruction that we are having is loop loop if equal, right? One more instruction that we are having is loop if equal. What is that? It will see sometimes what happens, that you have to execute a program if the two, if suppose you are comparing two arrays, right? you want to you want to compare, like you want to stop when they are not equal. You are comparing two arrays, say of 10 elements, right? And you will continue the comparing, like first element you have compared, second element you have compared, they are equal, then you will go to the next. Then again you will compare the next element, right? Then if they are equal, then you will go to the next. You will stop when you will stop, if they are not equal. That means you are executing your loop if they are equal. Yes or no? So what exactly you are doing here? Again observe your operation, observe your steps. What you are doing, you are having two variables, right? Two arrays. You are taking one element from each and you are comparing them. You are using compare instruction with that, right? Now if they are equal, then what you will do, if they are equal, then what you are going to do, you are going to check if after this, if 0, if they are equal, then you will decrement your count. If they are equal, then you are decrementing your count. That means one comparison is already done. Then you are going for the next comparison. And then you will, so if you will observe here your operation, then you are having one compare instruction for the current situation of your pointers, right? Then if they are equal, then you are decrementing your counter because you wanted to compare 10 elements. Now already one element is compared, now 9 elements are remaining. So you are decrementing your counter. That is the second operation that you are performing here. And after that, if after decrementing even, so both conditions are satisfied. Which two conditions? Either of them is satisfied. What is that? Like your cx is not yet 0. That means all the comparisons are not over yet, and still they are equal, right? If that situation occurs, then you have to go for the next execution. That is done by this loop equal instruction. What it does, it checks, is your cx 0? If cx is 0, what is the meaning of that? That means all comparisons are already done. If it is 0, then also stop. You have to stop after that, right? If it is not 0, and if your zero flag is your zero flag becomes 0, when zero flag will become 0? When zero flag, when zero flag will become 0? Elements are not equal. Zero flag will be 0, right? Zero flag is 1 when both are equal. Yes, result is not 0 when the both are not equal. That is Yash is correct here. Urjit, the result is 0, but when result will be 0, see, zero flag will be 0. What is the meaning of that? Zero flag is not activated. That means result is not 0. When result will not be 0? Urjit, Priyank? Yes, Abhi is correct here. Result is not 0. When the result will not be 0? When the numbers are not equal, right? So that is the thing here, that if uh,
Number will be equal, the result will not be zero.
number will be equal, then subtraction will be what? If number are equal, then subtraction of them will be, compare instruction is going to subtract them. If number are equal, then subtraction will be 0. That means 0 flag is 1. If number are equal, subtraction is 0. That means 0 flag is 1. Getting the point? So what I want to do, if my 0 flag is 1, that means number are equal, I want to continue. Right? So when I want to continue in this loop, in this example, when I want to continue, when I want to jump to the next, when I want to continue in the loop, when they are equal, or yet I am in the one when they are equal and my Cx is not 0. Both of the condition must be correct. Are you following here? Yes. So 0. What is, so when I want to continue in the loop, so here I want to continue if my numbers are are equal, that means my 0 flag is 1. Understood? And my Cx is not 0, that means I have not completed all 10 elements. Then I want to continue with the loop. Following the case? All of you online students, are you following the case? Okay, so that is what is done by loop if equal. Loop if equal, right? So
CX and 0 flag comparison we have to do ourselves.
Comparison you have to do. The comparison part will not be done by loop. That is a very good question here. What is the question? That do we need to use compare instruction? What exactly will be done by loop? Loop simply will check, is Cx 0? Then stop. If Cx is not 0, then it will check is Zf 1? If Zf is 0, then also it will stop. Right? Both of the conditions are true, then it will go to the label. Understood? So that to make Cx 0 and to make Zf 1 or 0, for that we need to use compare instruction. Yes, because it is a loop instruction, it is going to decrement Cx. You don't need to decrement Cx, that is okay. You don't have to decrement Cx, but yes, 0 flag, for 0 flag affecting 0 flag, you have to use compare instruction. Okay, so compare instruction will be external. It will not be executed by loop itself, but yes, decrement Cx will be done by itself. Loop itself does that. Okay, so now what is the next one? That is loop not equal. Again, if I want to check whether the element is equal or not. If they are not equal, it's okay. But if they are equal, I have to stop. Kind of thing. The reverse operation, right? What is the question here? First, all set to Cx. Yes, we have to set Cx. True. We need to set Cx first. I think we need to take one program after this, so it will be even more clear. Definitely, we will take an example, so it will be very clear. But yes, we suppose I want to compare 10 elements. Na? At that time, I have to set Cx 10. Cx value you have to set, but decrementing it will be executed automatically by this loop instruction. Okay, loop not equal will be what? If they are not equal, till time it will go to the location. That means your till time your 0 flag is 0, it will go to the next label. So what you have to check here, that all the elements are not completed. That means Cx is not 0. It is decremented, but you have not completed all 10. That means Cx is not 0, right? And your elements are not equal. So when not equal, that means 0 flag is 0 at that time. So getting the difference here between these two? Are you getting the difference of these two, all of you? Okay, so let me give you one program, just a second. I'm giving you one program, and then we can start executing. Okay, so the program aim of your program is that check all the numbers in the given array of 16-bit numbers are same. All the numbers in the given array of 16-bit numbers are same. Assume the length of your array is 5. What is given to us? Length of our array is 5. length is 5, right? So length is 5. And what is the size? 16-bit number it is. It is having 16-bit number. So we have 16-bit, one 16-bit number, second 16-bit number, third 16-bit, and fourth 16-bit. 5. Such 2 arrays we are having. Then we have to check whether all these 5 elements are same or not. If they are same, then make AX FFFF. We can have that printing appropriate message as well. Now you have studied that printing using AH and AH09 and integer 21, that you have studied, right? But if not, then it's okay. We can go with this. That is okay. So if all the elements are same, then write FFFF. And if they are all elements are not same, then write AX is equal to 0000. That means AX is 0. It indicates all elements are not same. AX is FFFF. That means all elements are same. So it is 16-bit number, and this is stored. It is stored at location some. Uh, okay, so we are comparing, or rather, let us keep it even simplified. Let us not do this comparison that we will do later. Even let us check this all elements of this array itself is same or not. Compare these 2 elements itself, like 5 elements. Compare them among themselves. That is also okay. Let us do that. Store this in variable, some memory location, say array, that is defined in the data segment, right? So whatever location that you want to keep, but 5 elements are there and they are equal or not, all the elements are same or not, that you have to do. So use this loop equal, whatever suits you, and write this program. What is that? We have array of 5 elements. We have to check all the 5 elements of the array is same or not. All the 5 elements are same or not. So start working on this and give me the code in your chat box so we can check, we can verify. 5 elements are same or not. As soon as you are ready, just give me your code here. It is possible that multiple answers we are having. I'm just being ready with my basic structure. I'm going to put your answers here only. So give me your answers. So first of all, tell me what will be the value of Cx? What should we keep the value of Cx? Yes, it will be 5 because again that depends that you are you some of you may keep the value 4. That is true. That again depends that how exactly you execute, right? So suppose you are taking first value itself, then you will need only 4 comparison, right? Prince, that depends, again that depends on your code, that how exactly you are placing it and how exactly you are decrementing it. 4 comparisons will be there because one element you are going to take first and then after. But again, possibly you are taking 5 and then you are decrementing in the code itself. That is possible. So Okay, so here we are having some load LEA SI array true. So you are taking effective address in SI, then you are taking that number in BX. Cable is correct here. In that move, okay, in CX we are having 4 increment SI. Okay, here Cable, we should we increment SI or should we increment it twice? Otherwise, it is correct. Otherwise, it is absolutely correct. Huh. Because of DW, we have to, yes, true. Because of DW, we have to correct it twice. So I think that code is clear to you, all of you here. What we are doing, if it is equal, so you don't have to compare, you don't have to check the zero flag again. See here, it will be easier. Otherwise, it will be 1 or 2 instruction more will be needed here. So all of you observe here. This code is correct so that we can go for the next program, next instructions even. So this is very simple here. It is absolutely correct. See what he has done, that array is somewhere defined in the data segment that you know how to define very well, right? And that value is taken in BX. So now BX has the first element of here. That first element is in BX. This element is in BX. Okay. And now CX has value 4, right? So we will keep in our mind that CX has value 4, right? Then what he is doing, he is incrementing SI twice. Assume that increment SI is there. That means now SI will point somewhere here, right? And then you are comparing these two, right? So first comparison is over, right? If they are equal, then you have to continue with the the next case, like you want to go for the next comparison, right? So yes, so if they are equal, then go again for the next comparison. Again, here it is going to increment, SI is going to get incremented twice. Keep in your mind here, increment SI twice is needed, or add SI2 is needed. Okay, so again it will point here. First number is already, if they are same, then no need to change the numbers here. First number you can compare with all. So the first number again is compared with the next. If they are equal, go for the next. If they are not equal, suppose they are not equal, somewhere in the middle they are not equal, then what will happen? It is not going to go for the same. It will go for the next instruction somewhere after loop, right? So after loop, what will happen? Um, yes, here I think Chintan has given, yes, array, he has defined the data segment. All of you can check your, okay, we will go to Chintan's code, but all of you are clear with this? After loop, what should be the instruction? After cable solution, after loop E, what should be the execution and where I should define AX value? How it is not yet completed, right? How will you come to know that all the how you will come to know how we will define AX and all those values? I need to go for AX value. No, what you will do? AX I have not defined here. Cable, where you will put your yes, compare CX with 0, 0, then JZ done. Okay, value of CX you can use because CX is 0. Yes, you can check if CX is 0, then you can go for some location where you are going to adjust. Yes, CX will be 0 if they are all equal. Otherwise, CX will be non-zero. Yes, you can use value of CX. No need to define one more additional counter. Are you following that? If all the comparisons are fine, all the 4 comparisons are done, then and only then CX will be 0. Otherwise, somewhere in the middle, suppose these two are not equal, at that time CX value will be 3 and you need to stop. All of you are following this, right? So yes, it is, yes, you can use value of CX there. And I think, yes, compare, yes, Chintan has done the similar one, but Chintan, again, you have made the same mistake. Increment SI will not be there, increment SI twice, because your array is of 2 locations, not sufficient to point 1. Chintan, are you clear with it? You are there? Okay, so that's good. So increment SI should be twice. Okay, fine. So this is all about this loop instruction, loop E instruction, loop Z instruction. See, loop E, why it is loop Z as well? Can you understand it? You are checking if it is equal, right? How you are checking if they are equal? By zero flag itself, right? So that means if loop if equal or loop if zero, the same thing, na? Right? So that's why or you are checking if loop is not equal. When you will come to know they are not equal? By not zero, by not zero flag, right? So that is why they are same instruction. See, you can use NE or NZ. Both are valid instructions in this. Same way, JE and JZ are same. JE and yes, jump if equal and jump if zero. True. That is true. Okay. Now we are going for the shift instructions. We are going for the shift instructions. Shift, you understand what is shift? We have to move by some bits. So first is shift left. See, here we are having more options. Here we are having, like, we are having shift instructions. We are having rotate instructions, which were limited in 8085. 8085 you have already gone through, but only similar instructions were there, right? Here shift and rotate are different instruction, one thing. And in the shift also, in the rotate also, we are having so many options. So let us learn that what exactly those options are. One is shift left, and again is this is shift right. Okay, this is shift arithmetic left, shift arithmetic right. Okay, now these two are shift left and shift arithmetic left are same instructions. Again, as these two instructions were same way these two instructions are same. Shift arithmetic left or shift left, both are same instructions. Yes, shift right and shift arithmetic right are different instructions. Okay, what is the change? We will learn. Okay, but what is shift left? Let us start with shift left. What do you understand? What is that? So suppose I have some beats. These are, suppose my I have this is my word or my byte, that depends on your shift operand, right? You can have byte or word, both of them. Shift left means what? What will happen to this LSB? Where it will go? It will go somewhere here. Shift left. It is shifting left hand side. Then this will shift here. This will shift here. This will shift somewhere here. What will happen here? That it will go to, where it will go? It will go to carry flag. Yes, this will go to carry flag. Understood? And suppose it is shifting here, this will be some empty place now because it is shifted. So what will happen to this location? That will be 0. This will be filled by 0. Simple operation. What is that? Shift left. That if then it will shift on the left hand side. LSB will be on the first beat will be on the second beat, and MSB will go to carry flag. And whatever the empty space is remaining at that time, 0 will be filled. Okay. Okay. Now you can specify that how many bits you want to shift. Here I told you with 1, but if I am writing SHL, my instruction SHL, then I'm writing my register or my destination. Destination can be your register or memory location. So your register or memory location, and I am specifying say 2. What is the meaning of this? Shift left by 2 bits. So this bit will come here, this bit will come here, right? And that is one shifting. Then again, one more time shifting will take place. So 2 times the same operation will get performed. So how many left hand side zeros will be added? If I am writing shift register 2, how many? Yes, 2 zeros. Yes, it is true. 2 zeros are added here. So that is what is shown here. Okay, so destination bits to be shifted. Okay, so if you want to understand that, what will happen? So this is, okay, let us observe this. This is my AX value. I am writing AX02. So first time what will happen? This is my carry. This will go in carry. This will go in carry flag. And my word will look like this. Any doubt here? My word will look like this. This green 0 is added. This green 0 is added after this. It is shift left. Any doubt in this? Anyone? Are you comfortable with this? Okay, great. And what about second? Second time what will happen? This from the carry will vanish. This will vanish. This will go in carry. and this 0 will come here. Here, I mean, all are shifted, right? So they are shifting. And one more 0 is added. This 0 will get shifted on the first location, and one more 0 is added here. So it will look like this. Okay. So what will happen? Okay, so now tell me, if I'm having shift left operation one time, it is actually multiplying my number how many times? Suppose my earlier my number was 1, right? I am doing shift left by one location. Yes, it is multiplication. Yes, it is multiplication with 2. You can observe already my AX was 1. Now after first shifting, what is my AX value? This is my AX value. This is my AX value. What is that value? Is 2. What is the meaning of that? My original AX is multiplied with 2. That is the meaning. Okay, fine. What about second time if I am multiplying? If I am multiplying 2, that means original number I am multiplying with 4. True. So shift left by 1 is multiplication with 2. Shift left by 2 is multiplication with 4. And this operation is much more faster than multiplication instruction itself. Right? So suppose if you want to multiply with 2 or divide by, if I want to divide by 2, then what you will do? Shift right. You are going to go for shift right. So multiplication, division by 2, use shifting operations instead of multiplication for the faster execution. So, okay. And what about shift arithmetic left? As I told you, they are same. These two are same, right? So actually we'll say, okay, if they are same, then why we need, what exactly is the difference between this right and this arithmetic right? Actually, it is preserving your sign bit. It is preserving your sign bit, right? In shift right, what will happen? In shift right, what will happen? Like suppose this is my simple, if I'm going for shift right, I'm not going arithmetic right. Arithmetic right will preserve sign bit. Whatever your sign bit is, it is preserved. Okay. So right, yes, true. Janil and Preet, you are correct here. It will be divided by 2. If shift right, it will divide by 2. Now the question is that what is the difference between shift right and shift arithmetic right? I told you this shift left and shift arithmetic left are same. But what is the difference between shift right and shift arithmetic right? So simple is MSB is preserved. In arithmetic, this MSB is preserved, right? So what will happen? Suppose it is right, so it is shifting like this, right? And this last bit will go, LSB will go where? This LSB will go in carry flag. This LSB will go in carry flag. And if it is shift right, whatever is places are remaining here, whatever empty spaces are here, that are filled with 0. And if it is shift arithmetic right, then empty places are filled with what? Empty places are filled with what do you think? Your sign bit. Original sign bit, it is used to fill these places. If it is 1, it is filled with 1. If your sign bit is 0, it is filled with 0. Are you comfortable with that? All of you? The difference between shift right, what is it? It is filled with 0. The shifted places are filled with 0, fixed. In shift arithmetic right, if your MSB earlier on the original number, if it was 1, then what will happen? If original 1, then 1s are filled, and if it is original sign bit was 0, then 0s are filled. So that you can see here. That we can do sign division? No, we cannot say that because number will get changed here, right? We are just preserving sign bit. Sign division will not be there. That you can verify. Okay. So division part will be true if it is unsigned. So suppose that division part, if you are using, that will not hold true in arithmetic right. Okay, that we can check. Suppose my so division part will be correct if it is shift right only, not shift arithmetic right. Okay, that you can verify here. If it is, if we can take a simple number even, right? Let us take a simple number. Suppose my number is say here 1 and all are 0, right? What will happen? So what will happen with this number? Whenever it is right shifted by 2 or right shifted by 1, then it will be 1 1 0 0, right? And then all zeros. That is what the number will be. It is not it is not divided by 2. I mean, it is not. I mean, these two numbers are not having that relation that it is this number is half of this. It will be true if this number is 0. Then and only then it will be true. I hope you are following the case. Yes or no, all of you? That division by 2 will hold correct in which case? Here only. So division by 2, division by 4, if you want to do, you have to use shift right only. You cannot use shift arithmetic right. All of you are following this? Are you with me? Are you following this? Great. So now let us go for the programs. Let us do that quickly. We can do the program. So first is count number of ones in the binary representation of given 16-bit operand. You have to count that how many times 1 appears in the given number. So start working on this. How will you do that? How many times 1 occurs? Suppose my number is this, then answer should be 1. Suppose my number is this, then the answer is 1, 2, 3, 4, 5, 6, 7, 8, 9. Answer should be 9. Because 9 times 1 appears in this number. You can assume that the number is of 16-bit. And if the number is FFFF, check carry flag, yes, true, logic is correct. That check carry flag every time it is shifted. Right? After performing left shift, check carry flag. If it is carry flag is 1, then increment the count, otherwise not. Yes, true. So logic is clear to all of you. Now we will not write that program. Let us go for the next program. So that it is also similar, but logic is good here. Tell me what you will do in the next program. Next program we are going to write. Right? Both are related. That is the hint to you. How many bits are similar in the given two 16-bit numbers? How will you come to know?
XOR both the numbers and then
That is absolutely correct. Yes, you have to take XOR of 2 bits, bits. It will be 2 numbers, but yes, bitwise XOR. So yes, you can take that. True. So you are correct here. What is the case? You have to take XOR of 2 numbers. XOR will be 1 if both the digits are. What will happen? Both the digits are. When XOR will be 1, different. When different, yes, when they are different. Then what you can go for? You can subtract it from 16, the number that are same. Count the number of similar bits in that way, or you can go for that. You can check that how many times 0 occurs. Then also it is okay. Okay, so start working on this. I need program. Similar bits you need to find. As soon as you are ready, just give me your code. Are you ready with that so that we can quickly go through the answers even that you were interested in? So once you are done with the program, let us quickly discuss the solution so that you can be clear with any doubt in case you have. The DAS part, DAS one was from madam's side, so I think that you should ask her, right? So that will be better. Yes, Priyank has written some code here. So two numbers we are having. Yes, Prince has also completed. So there are two numbers we are having. BL has kept 0 and CX has taken 16 because 16 comparisons are going to be shift AX, shift left by 1, and if carry occurs, go to next. That means if carry doesn't occur, then you are going to incremental BL, and you are going for loop next. Seems correct. That is, it seems true. Because see what will happen, increment BL every time when 0 occurs. If not, just a second, if not carry, here what you are doing, Priyank, that you are calculating once, if I am not wrong. BL has number of same bits. Yes, we have to find out how it will be same bits. What is the question that we have to find out, same or different bits? Similar bits or different bit? What is the question to you? Just a minute, let me verify. Similar bits, how it will be similar? See, just if carry occurs, if carry doesn't occur, what is the meaning of that? When carry doesn't occur, that means that is zero value. Zero will means what? They are, that bits are different. That is the meaning. Yes, so yes, it is same, and carry flag should, if carry flag is 0, what is the meaning of that? When carry flag is 0 is what? When carry flag will be 0, when that number will be 0, when that number will be 0, when the bits are, yes, the bits are same. Yes, so if it is not to 0, I mean, that is, I think everyone is comfortable with this. So the logic will be this, of course. What is that Prince has written? Move X, and if JNC L2. Okay. Why you are jumping to L1? Prince, here we want to write here anything else? Prince, you want to write something else here? What is L2? Why you are jumping to L2, which is the next instruction itself? You want to go for L1? Keep shifting till. Uh, is that the case? I mean, I think we have very limited time. Only 5 or 6 minutes are remaining. But I think all of you are comfortable with this logic. Do you need me to discuss it? You are clear with the logic. It seems that you are clear with it. Should we discuss? If you need, then we can definitely discuss. What you have to do that, just compare the XOR different. You want to count out the different bits, then what you have to do? If they are, you have to check for carry flag is 1, and if you want to count out same numbers, then you have to check that carry flag is, when carry flag becomes, wait, when your carry flag will be 0, when the numbers are same or numbers are different. When numbers are same, at that time carry will be 0. Okay. Answer for this is this one. How? One more thing that you have to take care here. What will happen? That increment instruction doesn't affect carry flag. Increment instruction doesn't affect carry flag. So what will happen? Move instruction will not affect any flag, right? Then add BL by 2. What will happen with this? So BL has become 5. By this, BL has become 5, right? Then BL, now what you are doing, that BL is subtracted, you are subtracting 6 out of that. So now what is the BL value? BL is -1. What is the meaning of that? How it will look like? It will look like FFFF. -1 is represented as FFFF, right? And then you are adding 1. You are adding 1. So what will happen to this FFFF? It will become 0. So this value is going to be 0. And what will happen to carry flag? What will happen to carry flag after this? Carry flag is 1 because you are adding 1 to this, right? Up to this L1 is clear, na? And then you are incrementing BL. So now what will happen to BL? BL will become 1. Now based on this answer, this sign flag 0, 0 flag 0 because answer is not 0, right? Parity will be 0. Yes or no? Because you have to go for odd parity. It is already one number in that. So it is odd parity already. And yes, it is affected. See, it is affected. But we are interested here only. We are interested here only. Are you getting it? We are interested in this part. Yes, of course, here it is sign flag is affected. I am asking here it will not be affected. Carry flag will remain 1 because of this. Carry flag will not become 0 because you have added 1 to the 0, 0, 0. Is it clear? So definitely it is affected. But in the last step, so this is my final answer. Okay. Now, which of the following instructions are not valid? So this instruction, because you cannot directly add to DS, and this instruction, because you cannot have memory to memory transfer, these two are not valid. Other instructions are valid. Okay. Okay. What about address bus size? This is very common, very known question. What is that? Yes, it is 20. So answer is correct here. It is 20 bit, not 20 byte. Okay. This will take time. Definitely, we will take in next. This is one. And for answer for this, I think this is also correct for all of you because that format you just have to use that you can verify. Again, no need to check this. That format is already given to you. Yes, here what you can check is that here also two answers are there. Which are those answers? That from CX to AX, that one, right? And to AX, I mean, from and to that you have to consider that content of CX to AX. That means you are writing register part. You are mentioning register in CX and you are writing your D as from. That means whatever is specified in register from that, or in that register part, you are having that AX, right? And you are writing your D flag is indicating 2. Your D flag is indicating 2. That two type of instructions we have taken. So those two answers are going to come here, right? So definitely, see, actually we are running out of time. I think these two instructions that are simply codes, so I'm not going to solve them. It is already covered. I will cover this question and any other question if you need. Okay, here it is very simple. What is that? You have to take 348A0 and you have to take IP only because it is given CX. So that will be 4214 is added here. So answer is going to be this. Is it clear? And here, what is the case? What is the answer here? Is the size 64 MB? Is the size 64 MB? KB. Is the size 1 byte? Minimum size? No, it is not 1 byte. What it is? 16. Right? It is 16. And this is true. You are capable of addressing 1 MB memory. So according to that option, you can opt for. Okay, is it okay to you? Other questions we will solve in the next. That is after solving this. Okay, so let us do that.